Hello. In this video, we'll talk about an example virus that gives an attacker complete control over an infected machine. In order to establish network connections, you first need to know the IP address of the host and then initiate the connection. Imagine you have a corporate network that is protected by a firewall on the left. It's extremely hard for an outside attacker to initiate connections to these machines because they could be using non-public IPs. In addition, any outside connections will likely be screened by a firewall with very strict rules. If you have an internet connected server and look at connection logs, you'll be surprised by how many random attempts are made from people trying to get inside your machine. There are tools that can scan random machines and just keep trying weak passwords to see if they can log in. There is something called a reverse shell that are used by attackers to circumvent various protections. Instead of having an attacker initiate a connection from outside, a reverse shell is started from the inside, and the attacker takes on a passive role of waiting there and accepting connections. Because the connection is initiated by an inside machine, it's extremely hard to be blocked by a firewall, as it cannot reasonably tell if the connection is intentional or not. In reality, you would need sophisticated system monitoring for suspicious command execution and track all outgoing connections to detect a reverse shell. It's very difficult in practice to get things right without false positives. So the whole idea is, if a victim machine runs an infected program and executes a reverse shell virus, we will be able to gain control of that machine. For this virus, we have put a reverse shell inside, made it infectious, and tried to hide its connections in the background. If you're interested in a step-by-step explanation of the techniques here, I recommend you to check out the full virus engineering course using the link in the description below. Let's see this virus in action. We will first build the virus. And also, let's build the infector tool. Then, let's infect the PWD program. In another terminal, let's run netcat and listen for incoming TCP connections. I want to make it feel more realistic by opening a terminal on my Mac outside of our development container to simulate remote connections from a different machine. Before we do anything, let's run ps to show the currently running processes on the infected machine. Right now, we have the Z shell process as well as the ps command I just ran. Now, let's execute the infected program. And the terminal on my Mac has access to a shell for the Linux development container. It looks a bit weird because it's raw I/O over a socket. We can follow these steps to promote the shell to a fully functioning bash with command history and colors. First, let's upgrade our shell to bash. And this is how we get our prompt back. Then, let's background the current shell. We also need to update the local terminal line settings. And then, let's get our color back. Let's head back to the victim machine and see the current running processes. And indeed, we have one more shell process that is being used by the attacker. Pretty cool. This shell works just like what you would get when you connect to a machine via normal means like SSH. We can even spawn a Z shell on top of this. You get full command history, and a fully functioning Vim editor. You can poke around just like your own machine. As you can see, as soon as the infected program is run, a reverse shell was spawned and gave an attacker basically complete control, just like a normal user. If the same reverse shell virus infects a large amount of machines, the attacker can potentially build an automated service waiting for infected machines to connect, and then drop more viruses on them. I hope you are having fun and get a chance to test this virus. In the next video, I will show you how a fileless virus works.